Hi everyone, I'm Simon Massey. I'm a senior lecturer over in sociology and deputy director of the Manchester Met Q-Step Centre. I'm going to be talking you through day 2 of our very gentle introduction to Python using Google Colab, also known as how to be a data scientist. So you've gone through that first day, you've started to learn how to program or code certain lines of code that produce little bits of information from a data set. And today you're going to start learning how to really analyse data. Now, what's quite funny, I think, about data analysis is if you Google it, you often get a misrepresentation of what data analysis actually is. You get sometimes people looking at a huge screen of just zeros and ones, or you'll get something from Homeland or 24, and that all looks very exciting. But I can assure you that data analysis is actually much more simple than that. Most of the time, data analysis requires using a software to analyse data to tell you the information, and then you take that information to enhance a particular story. That's usually what a good data analysis would do. So what we're going to do now is talk about some of the statistical concepts that are in day 2 that you've been learning how to code. So let's do this. Now, there's 2 types of data that you're going to be working with, and those types of data are determined by whether they are categorical or numerical. Now, an important thing to mention here is that there's different words for the same thing. So for example, with categorical data, which is data that you put into categories, that can also be regarded as a factor, and it can also be regarded as a string. There's one thing that we like to do in data analysis, it's to come up with different names for the same thing. So categorical, you might come across the word string and also factor, and then numeric also has different names. The other names that you can come across are scale, that's something we use commonly in social science, same thing as numeric. There is also interval, and there's also continuous. So lots of different names for the same thing, but be sure to have a look at the resources we've left, and you'll see that whilst we use different names in different departments or different fields, it is actually referring back to the same thing. So back to our main point, 2 types of data. The first type of data we're going to talk about is categorical data. And categorical is when you are provided with information that will put you into a particular type of category. And I often think and tell my students to think of categorical data as data that describes you. Okay, so the first thing that we always talk about is gender being a categorical variable, because gender is a category that we put ourselves in, whether we identify as one gender or another. It's not necessarily a numeric variable. You can't have an average gender or a maximum gender. What you have are different categories of gender. Same for things like ethnicity. Age can of course be categorized, religion, location, the team that someone supports, the phone they have, whether you have dietary requirements or not, the type of dietary requirements you have, your marital status. There are so many things that can actually describe us as a person, and that would all be recognised as categorical data when inputted into a type of data set. So if you think about the type of analysis that Facebook or TikTok or Instagram will do, one of the first things they'll be doing when they're analysing your data is thinking about what kinds of categories you fit in. You can also think about things like favourite sport, that can be a category. So categorical data essentially is when you have categories or groups. Numeric data, on the other hand, is when you don't have categories, and that's it. That's the only difference between categorical and numeric. And what you'll notice on the slide I've provided is numeric data is data that just carries on. That's why it's called continuous sometimes. There's no groupings of any sort. It has a minimum, it has a maximum. And that's why the type of analysis we see on categorical and numeric data is very different, because the nature of those measurements are quite distinct from each other. I've given you some examples of classic numeric data. Age can still fit into that, but think about height, how high you are in inches or in centimetres. Weight, the number of times you've seen your friends, your shoe size, how hot or cold it is today, the length of something, even the volume of liquid. That is all regarded as numeric data. Now, when it comes to using these types of analysis on Python, or on Google Colab, or whatever it is you're going to be using, it's really important you recognize the measure of your variable, because you will find it, I do this all the time, if you haven't looked at what kind of measure your variable is and then you try to do some sort of analysis, you might get error codes For example, if you try and look at the average gender and Google Colab hasn't produced it for you, that might be the reason why. In addition to, of course, not coding it right. So let's have a look at how we analyse numeric data. What you see here in this slide is the command that you enter in Python or Google Colab or whatever it is that you're using, and what it actually means. So hopefully you'll find that this is quite helpful. So for example, if you've been instructed to enter the mean for a particular numeric variable, what that is you're looking at the average, where you add up all the values that have been given to you and you divide it by the number of values that are provided. So for example, if you have a sample size of 6, you will add those 6 numbers up and divide them by 6. The mode is a lot more simple than that. It's just the most common number. So which number in your sample has come up the most? And then median is the number which is right in the middle of your sample, but when you put it in order. So you put it in order from lowest to highest. Whatever number is right in the middle of that range, that is your median value. So that's what mean, mode and median are. Now they were my 3 least favourite words at school because I always forgot what they meant. But hopefully this resource here, that puts it out there for you so you don't have to remember it off the top of your head. Hopefully that's going to help. Now, the others are a bit more simple. You've got the maximum, which is just simply the highest number available. So if you're entering on Google Colab max for the variable you're looking at, it'll just give you the highest number. Minimum, it's just the other side of that. It's the lowest number available. And then STD, that stands for standard deviation, which is essentially the average variation from the mean. So you're going to have a mean value. Standard deviation tells you how much on average do we deviate from that mean. Now, if you want to learn more about standard deviation, we've provided you a video on that as part of this workbook. But right now, you don't need to know the ins and outs of how standard deviation works. I would say go and have a look at it because it is pretty interesting. Right, so let's have a look at how mean and median can differ so greatly from one another depending on your sample size. What you have here is an image of some people out on the town, some young professionals enjoying themselves, and what we're going to do is we're going to put their salaries up there for you. So as you can see, this chap here is on 28, the lady next to him 33, it goes up to 35, 37, 45, and then the lady at the end here is on £51,000 a year. Now, if we wanted to look at the mean, we've done this for you, we simply add those values together and divide it by 6. So you add those salaries up, you're going to get a total of 229,000. If you divide that by 6, you get 38,000. So that 38,000 is your mean. That is the mean salary or the average salary for this sample of 6 people. The median is when we look right in the middle of that order. So if you think that we've got 6 different numbers here, that means we're going to have to go in between 3 and 4. So number 3 was 35,000. 4 was 37,000, so your median is 36,000, right in the middle of that range. So straight away you can see they're not majorly different, but they are different. The mean and the median values are different there, and that's why it's important to look at different kinds of averages. Let me give you another example of why you should always double check these things. Let's add Elon Musk to our sample. And according to my Google search, Elon Musk is on £269.7 billion per year. So if we add into that, our mean or our average is going to change quite distinctly, because the average adds up the number of people divided by the actual sample size. So our total is now 269.7,229,000. If you divide that by 7, your average is 38.5 billion. So now our sample size, even though it's only increased from 6 to 7, our average, our mean, has gone up from 38,000 a year to 28.5 billion per year. So as you can see, the average has been really influenced by that extreme value, that new maximum value. However, if you use the median, it's not too different. It's only gone up by 1,000 from the original 37,000 now, and that's because we have a sample size of 7, and the middle value is that 4th value there, 37,000. So now you can see that the mean and the median are very different to one another, which is why it's always important when we look at all of our averages. Let's have a look at the mode, because the mode is a tricky one. Mode is a simple thing in that it's the number that comes up the most. But in addition to that, you can actually have no mode, or you can have multiple modes. In this example here, we've only got 7 people, and each of those individuals has a different salary. So in this instance here, we have no mode. When you're working with larger volumes of data, there's a good chance you will have a mode. There's also a good chance you'll have more than one mode. You can have 2, 3 or 4, depending on how often a number comes up. That's something that you can't control, but it is something you can identify by simply entering the command mode on Google Colab. So looking at this data set now, if you were to enter some code, you would see that the minimum salary was 28,000, maximum was 269.7 billion. Right, let's talk about the importance of measurement and how the way that we've measured a variable and decided whether we're going to report it in its numeric form or categorical form can change the story, or at least provide a different sense of narrative. What you can see here on the slide is some data that we did, and what we found was that the average number of weeks that someone waits before breaking wind in front of their partner is 25 weeks. So what we have there is a scale variable. We've asked people how many weeks do they wait before breaking in wind in front of their partner, and they've given us a number. So all of those little farts that you can see there, they are the actual number that the person's provided. So we can see that the first person said 4, the second said 5, another person said 8. So thinking about that for a moment, the average number of weeks being 25 weeks before someone breaks wind in front of the partner, what do you think to that? Do you think that's high? Do you think it's low? Do you think it's about right? But what we can do with this data is we can actually categorize it. It doesn't have to be scale. And if we categorize it, we might get a different story going on, or we can at least find out why that number is the way it is. So what I'm going to do with this sample is start breaking it apart. So now I'll put it into 2 categories. As you can see here, we have now got 2 categories, 20 or below and above 20. And all we're doing is we're taking that numeric data and putting it into a category that we have decided to create. So I thought, given that we had a nice sample, I thought let's just break it apart, and it looks like if we break it apart we almost get a half and half split, 20 or below and above 20. You can of course also have missing data, so this blank answer here, that's just someone who's declined to answer the question, and it's important that you look at when you've got missing data because it can be really important when trying to tell your story. Now I'm going to break this data apart even more. So let's say we've got 20 or below, but then we want to put it between 21 and 40 and then above 40. And now we've got 3 categories. And essentially those categories have been created based on the number of weeks, and we're using 20 weeks as a sort of cutoff. So you've got 20 and then between 21 and 40 and then 40 and above, and I think the maximum was 52 weeks. So you've got 3 categories there, relatively even split. Let's break it down even more. We can break it down and put as many categories as we like. So now we've got 10 or below, 11 to 20. And essentially the number of categories you can create, the list can go on. And essentially, when you look at how many times you can recreate a variable and categorize it, you can start to see how your groupings can really change and how the size or the volume of people in a group might change. It's really important to recognize that, especially when you're trying to analyze your data later on. So what you have now is a frequency table that's produced a pie chart, and this pie chart is showing you the percentage of people, how long that they wait before breaking wind in front of their partner. This looks very different to the statistic I gave you at the beginning of the video, which provided you one number, which was 25 weeks, just one average. What you can see here is different categories now, and looking at this we can see that the most popular category is between 2 and 6 months, and that was the orange slice of pie at 29%. So, as you can see, it's not that it completely changes the story, but it does give you a slightly different narrative just by changing the measurement. What you see in this slide is how we can use different measures for the same variable. So the first 2 words that we're going to talk about are nominal and ordinal. They are both regarded as categorical. Nominal is when you have no hierarchy in your categories, and ordinal is when there is a hierarchy, you can highest to lowest. Scale is when there's no categories. So what you have here is how an example of how age can be measured in 3 different ways. As you can see in the first one, we've got age as a categorical variable where you have below the age of 40 and above the age of 40. And we often recommend to use a pie chart when working with nominal data that has categories with no hierarchy. The second example is where age can be recognized as a categorical ordinal variable. And the categories here are between 10 and 30, 31 and 65, 65 and above. very similar to how we measured age in the Titanic data set. And then in your third example, we can see a histogram that visualizes age as a scale variable, where there are no categories at all. And we recommend to use these types of charts when visualizing your data to help you tell a better story. For example, if you try to do a pie chart for scale, you are going to have lots of slices of pie. And let's be honest, whoever wants a small slice of pie? Let's have a look at Google Colab now and see how we can start analysing numeric data.
Before we go to understand the data, we need to make sure that the data set is imported. Simply run the cell using the .head method, and that should show whether or not the data is imported. So first we can start by creating our own table of stats. Now, even though the .describe method does return the statistical values for the quantitative columns, such as the age and stuff, it's a good idea to be able to do it yourself. We can run this individually using the inbuilt methods, like the .mean, the .median, and we're going to run this each and store them in their own variable, like age mean, age median. Then we're going to use a data frame, which is the pandas library, and we're going to import a dictionary, which you saw yesterday. Now, the key is going to be the column name, and the value is going to be them variables we just created. And if you run that, you'll see you're going to get a table. And we've done the same there for the fair, just so you can see if you've got more than one version of it. But we don't just want to be able to run stats on quantitative data. There's a lot of categorical data out there. In the Titanic data set, the main one is the where you embarked. So there's 3 places, the S, the C and the Q. It's Southampton, Cherbourg and Queenstown, different places you could get on the ship. And we're going to run the dot value counts, so data, and then we want to siphon out the column name, which is embarked, and then we're going to run dot underscore value counts, and that'll give us how many values for each of the different categories there are. So in S there's 644, then in C there's 168, and in Q there's 77. We can then, if we wanted to maybe have them as the actual names, we could use the dot replace, and then we pass in a dictionary again, with the key being the data that's in our data set, so that S, that C and that Q, and we're going to replace them with the names, so Southampton, Cherbourg and Queenstown. You might also want to show the percentage, so not just the actual how many values there are, but the percentage of values. And for this we're going to do, again, we're going to store the first one in a value called C, so that's just data, and then the dot embarked is like using the brackets and the speech marks, it does the same thing. And then we're going to do dot value count to get the values. For P, what I've done there is by passing in that normalize, instead of it giving back in terms of how many values, it gives back a percentage out of 100. That dot mul, that basically just multiplies it by 100 to get the percentage, and then I've rounded it to 1 so it looks a bit neater, and I've converted it to a string, and that's just good practice. If you want to display data, it's probably a good idea to convert it to a string. It's a lot more, you can manipulate it in a lot more ways and you can print it better. So actually on to plotting data, because it's all good and well being able to use the data in tables, but you want to be able to plot it with graphs. In Python we use the matplotlib library, specifically the pyplot section, and we're going to name that, and I've named it in the file as PLT, and that's just a standard programming convention. You'll find them on the internet. It's like pandas being PD, and you'll see that NumPy, the NumPy library, will be NP, and it's just a thing that someone made sometime and everyone sticks to. So for quantitative data, you're going to be looking at histograms. So you can simply make most graphs by doing PLT and then dot and then whatever the chart is. So for the first one, I've made PLT.hist, and then I've passed in the age data, and that simply just creates a histogram of the different ages that were on the ship. You can give it a X label, a Y label and a title, and then simply by pressing, or by typing the dot show and then run in the cell, you'll see that you get a small PNG that you can save somewhere if you wanted. You could export it if you want to keep it for later. But there's more than that you can do. You could make 2. So the second example, there is 2 histograms, and here I've made histograms of the people that survived and didn't survive based on the fare they paid to get on the ship. You can see that dot figure, and then when I pass in that fig size, Fig size will tell the library how big you want the figures to be. So obviously, if you don't pass in, it'll default to whatever the standard size is, but sometimes you want a bigger graph, sometimes you might make a graph too big and you want it to be a bit smaller. That dot subplot, that's simply I'm plotting two graphs at once, and that 1 to 1 just means they're going next to each other. 1, 2, 2 is just next to that. And this is the other way of plotting graphs. So you can see here, instead of using the plt.plot, I've actually grabbed the data first. So I've done data fair and then who survived from that data fair and who didn't survive, and named them in not survived and survived fair. And then I've simply done dot plot. I've passed in the variable hist under kind, which tells the matplotlib library I want to make a histogram, and I've passed in a title that way. So that's another way you can really easily make graphs. Next, we've got pie charts. These isn't, I mean, you can do both with this, but you're going to be making probably more categorical data. For the first example, you can see I've done it in one line, and I've done it on the number of males to females. The plt.figure, I've passed in a fig size before I've even created the plot, which might look funny, but you can basically, if it's in the same cell, it should be fine, and if it's not, you can probably just Google it and you'll find an answer. Stack Overflow has got enough to find if you've got a problem. So on there I've done data.sex.value count, and then I've this time, instead of passing hist, I've passed in pi. I've put the title, and then this OOPCT, this %d %, I just found it on Google, and it basically just says you can show the percentages from that, and there's loads of different things you can do with that, and I actually didn't know this until I came to this, and all I did was read the documentation and was able to find it, and that's probably one of the best ways to learn the different libraries of Python if you wanted to expand, is just going through and looking at the different things you can do and having a play, because at the end of the day, if it breaks, you can just go back and try something different. Another example, again, I've subplotted here, so I've made two pie charts. Again, this is for the number of people that survived and didn't survive based on what class they are. So obviously there was classes on the Titanic. I can't remember what they are off the top of my head. Again, I've done the fig size first and then the subplot. And it works in the same way. And you can see here I've used .value count for categorical, and it's just another way of, you can basically plot anything. I mean, just putting .plot and trying to do it, you never know. Moving on to bar charts. Bar charts are obviously one of the more, I use them the most in my analysis that I've done so far. So in the first bar chart, I'm doing it a different way. So I'm using that .group by. So what that's going to do is it's going to group all the data and store them in like little boxes basically. So it's going to group them by males and females. And then on top of that, in them boxes, I've then divided them even further by doing .survived and getting the value count of that. So there's obviously survived and not survived. And then by simply just .plot and then passing in again that kind equals and then the bar. So I could have put pie chart there, or I could have put bar. It doesn't really matter. And then this time adding the title and the labels after. You can see again it just makes the bar chart. But charts can be used for more than just showing and understanding the data, because there might be other things we want to represent that you might print out on a command line or just as text, but you want to see it graphically. One of the best examples for this is finding how many values are null or not in the data set, missing, which you'll look at in the day 3 notebook more, but this is a quick look. So again, yesterday there was the data.info, which gave you each column name and it'd give you the null count. And you can see for like age, cabin and embarked, there's data values missing. Another way we can try and represent that is doing data and then .isNA, which just stands for not a number. And that basically is how you represent null or nothing, empty in Python. And then by running the .sum on top of that, it adds all together the columns, so you don't see that massive table of false, 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 because it's unreadable. You'll never be able to extrapolate any data from that. And you can see on here there's 177 for age, and there's 687 for cabin. And that's all good and well that you can see it that way, but we might want to represent this graphically. So we can do this, and I've done this by basically running the data.isNA and storing that in a variable, but using this character here basically does the inverse. So instead of showing all of the null values, it's going to show all the values that are present. So basically when you plot that then on the bar chart lower, you can see that the cabin is really low because that only had, what was it? I mean, it had 687 missing. So that's probably the best way to represent is null data, and it's a really quick and easy thing you can do if you were looking at a new data set and you wanted to see how much is missing for each bit. And yeah, that's the end of the second broadcast on how to be a data scientist. Well done for working through the workbook. Don't worry about understanding everything because no one's going to learn to program in 2 days. It takes, years of hard work if you want to get really good. If you're new to code, it can be difficult, don't worry. Everyone struggles, even I get things wrong and make mistakes, and it's just about finding ways to overcome that and, Googling the right questions or looking at the documentation or asking the person next to you for help. There is a notebook, you can, go and run the notebook, and there is a section of the workbook with some exercises that have been prepared for today's session.